How you guys doing today? We are starting 8.5 variation functions. There are only 3 examples today. It is not that bad. You should have printed this out or have Notability open at the moment. So we are dealing with the direct variation, inverse variation, and a jointly variation. And all you need to do is memorize these green formulas here, and you should be okay. We're always going to be missing a particular variable. They're going to give us at least 3 out of 4 or 4 out of 5 and so on and so on. So we're looking for keywords here. So if we look at the first example here, it says if y varies directly. If it says directly, we're going to use this formula. So it says if y varies directly as x. So right away, we're going to just go ahead and label this as y1, x1, and then wants to find this y2, and this is our x2. So this is actually a linear type of function. If you look at this, it's a y equals mx plus b, right? So, but the m is actually the k. So all we're really doing is taking this and going k equals k. So another part to the question might be find k as well. So just understand that k is also slope. But what we're really going to do is just plug in what we know. So we have the y1, it's 15, right? We have the x1, it's 5. We don't know the y2, we do know the x2, right here, it's 7, right? So all we're going to do is go ahead and plug them all in and solve for the missing variable. It's pretty easy. So y1 here, we said it was 15 over x1 here, negative 5, equals y2, what we don't know, x2 we know, which is 7, and we're going to solve for y2. There's 2 ways you can do this. You can cross multiply, which is legal to do since it's a fraction equals a fraction, or you can go ahead and you can say I want to multiply both sides by 7. It's up to you how you want to do this. Okay, I think it's probably easier to do it this way. Sometimes you do have to cross multiply. So y2 is going to equal, or you can just say y equals, right? I'm going to go ahead and use our calculator right now. Okay. So I'm going to go 7 times, I'll put this in parentheses here, 15 divided by negative 5. And really that's just going to be, negative 3 times 7, which is going to be negative 21. Okay. So we are done. I'm gonna go a little bit further, and they're gonna say what is k, and it's just any one of these fractions here. So we have it pretty much right here. It's 15 over negative 5, which is negative 3. So that's what k would be. Okay, it's also like our slope. I want you guys to pause and try b. Okay, so by now you should have paused it. So and finished it. So it says r varies directly as t. So you can go r over t if you want. Kind of similar to what we have up top, right? It says y varies directly as x. So we have, if you want to, you can say r1 over t1, then r2 over t2. You can say that if you want, right? So this is our r1 right here. This is our t1, r2, which is what we don't know, and t2, which is we do know. So the one we're trying to solve for is this r2. Okay, so just putting it all in, negative 20 over 4, r2 is what we don't know, and then t2 over t2 here, which is negative 6. Once again, you can cross multiply, or you can just go ahead and multiply both sides by a negative 6, like that. Might be easier just to do it that way. Alright, and so r equals, and you could go ahead and reduce negative 20 divided by 4, which is going to be negative 5, right? And then that becomes positive 30. So that's what r equals. Okay, let's go a step further and let's also solve for k. Right, k is pretty much just this guy right here. Negative 20 over 4, which is negative 5. That's our k. Okay. Alright, we're going to move forward and go to joint variation. So it says y varies jointly as x and z if there are some non-zero constants. So if you look at where the equation derives from, is from y equals k times xz. So we got a lot of variables going on here. They're going to give us, so there's going to be 6 variables here, and they're going to give us 5. And we have to find the 6th one. Yeah, we're also going to solve for k as well. So you kind of got to get familiar with these formulas here. So it's going to be y over x times z. Okay? And we're going to start with the first one here. So it says, suppose y varies jointly as x and z. So right away when you see this, you got to look for the word here, jointly. So right away I'm going to write y equals y over x times z, like that. It says jointly, right? And it says find y, so the y1 we don't know. That's the one we're trying to find. And they give us an x1, they give us a z1, and see what else they give us. Alright, so this 9 goes here, this 2 is going to go there. They give us a y, y2, it's going to go right there. z2 and x2, right? So we have the rest of these guys here, here, and here. So we're just going to plug those all in right now. Okay? So I'm going to keep that formula up there so we can use that. So y1 we do not know. x1 we have 9 times 2 equals y2 we have, which is 20, over x2, which is 5, times z2, which is 3. Okay? So from here we're going to solve for y. Do not forget we can also get k. K is this guy pretty much after we reduce that. We'll do that at the end. So from here you can cross multiply, or we'll just do some work here. So this is going to be y1 over, this is going to be 18 equals, so everything equals 20 over 15, right? So we can go ahead and reduce the right side if you want to, or if you want to, just go ahead and just multiply both sides by 18. It's going to be the same thing for us. Okay. Alright, so y1 is going to equal this 20 over 15, which is it's going to reduce to 4 over 3 times 18, and you can see this cancels out, it becomes 6. So y1 equals 24. Okay. I'm just going to check with my calculator really quickly just to make sure I did all right. So 20 divided by 15 times 18. Yep, 24. Alright, in terms of k here, we just go ahead and we reduce, so this is 20 divided by 15. We did that earlier, so it's going to be 4 over 3. That's our k. Okay? Alright, I want you guys to pause and try the next one here. Okay, you should have paused and tried this problem already. So you want to read the first sentence here and make an equation out of it, right? So it says suppose r varies jointly. Okay, so r varies jointly, so you want to say r over v times t, like that, right? 1, 1, 1. Then r2 over v2 times t2, like that. So let's just start labeling everything here. This is a r1, v1, t2, r2, v2, and a t2. So these numbers that we have at the bottom, we call them subscripts, okay? It's kind of like saying if there's 2 James in the class, we would say James 1, James 2. That's what it's kind of like. Those aren't exponents at all. I should have gone over that, but I just want to reiterate it. So let's go ahead and plug everything in. R1 we don't know. V2 we have is 2. Or V1 we have, which is 2. T1, which is 8, equals R2 70 over V2 10 times T2, which is 4. Okay. And once again, if we want to solve for k, it's pretty much this guy, right? We'll do that at the end. Okay. I'm gonna skip a little bit of steps here because I know 2 times 8 is 16. So I'm going to multiply both sides by 16. Okay? Completely legal to do. If you want to, you can start producing stuff like, you know, you can say this and this, that reduces, that's 4, right? You can say this 0 and this 0 cancels out, so really we're just left with 7 times 4. If you want to do it that way. R equals 28 is R1. Okay. And for K here, so we have 70 over 10 times 4, sorry. It's going to turn into 70 over 40, cancel out those zeros, and we get 7 over 4. That will be our K. Okay? Alright, we're moving on to our last example. And this last example is inverse variation. Okay, this one gets kind of complicated, but we're looking for the word where it says inversely. Yeah? And the formula now is a little bit different. So I want you to please take a look at it. It says x1 over y2 is no longer y1. Okay, x2 over y2 equals x1 over y2 equals x2 over y1. So take a look at where these guys are located. They're located in different locations. All right. So if you don't understand what I'm saying, I'm going to try to color code this for you. I'll put this in red. So that's what I'm talking about right there. Okay, they're gonna give us at least 3 out of the 4. So we're looking for words that says inversely. So it says if x varies inversely as y. Okay, we're gonna write in, this is our x1 right away. x1 is 24. y1 is our 4. Okay, and then we have to find x2, and y2 is 12. So just plug everything in. Okay. So, x1 here is 24 over the y2 here, which is 12, right? Equals the x2, which we don't know what that is, and then the y1, which is a 4 here, okay? And we're also going to solve for k. The k is going to be a little bit different, but we'll do that at the end. So from here we can cross multiply, or we can just multiply both sides by 4, okay? You can reduce this. That becomes a 3 down below here if you want to do it that way. So it's really 24 divided by 3, which is going to be 8. So x2 becomes just 8. And to solve for k here, using this formula right here, k here is going to be x1 times y1. Okay. Sorry, my mistake. K is over here. K is over here. K is x times 1. Oh, sorry, it is x1 times y1. So it's going to be 24 times 4 pretty much. And that's going to be 96. Okay. Alright. Let's go ahead and try B. This is the last one here. Pause it. Give it a shot. Alright, keywords here, inversely, so this is A1. I like to write the formula out right here, like that, and color code this. A2, B2, like that. And let's go ahead and write everything in. A1, B1, A2, B2. Alright, let's plug everything in. 28 over -2, like that. Our color coded one more time. A2 we don't know. B to -10 we do know. B2 is -10, okay? And then we can multiply by -2 like that, both sides. If you want, these cancel out. That becomes a +5 now. And so A2 equals 28 over 5. Okay? And you can also solve for k as well. K is just going to be 28 times -2, which is going to be -56. Okay, just want to double check everything. Yep, and it looks good. Okay, so that's the end of the lesson. Your homework's at the bottom here. Don't worry about these reviews yet. I'll talk more about them later, but just go ahead and start an 8.5 homework. Okay, thank you.